Okay, today's classwork is just going to be a couple of examples. First thing that you should do is get out a separate sheet of paper so that you can write this down as your notes and submit as your classwork. So first thing we're going to do is just write down our product rule and quotient rule. Our product rule is used anytime we're multiplying two functions together. We'll call them u and v. To take the derivative of u prime, we cannot just take the derivative of those separately and multiply them. We have to use u prime times v plus u times v prime. That will give us our derivative formula. Similarly, quotient rule is anytime we are dividing. That's what quotient usually stands for. And here, to find y prime, our derivative, we are going to start the same way, u prime times v. This time we are going to subtract u times v prime, and we're going to divide that whole thing times v squared. You have a couple of options here. You could memorize these. You could keep them on your person and just refer to them, or you can use our chart method that we've been using in class. So we have to identify product and quotient rule and then use them effectively today. So the first one is certainly a product rule. I'm going to annotate u and v, and I'm going to come down and I'm going to make my chart with u, v, u prime, and v prime. And I'm just going to draw on that chart what those functions are. This one's going to be 3x squared plus 2x plus 1. And this one's going to be 1 over x plus 1. From here, we just have to take the derivatives. This becomes power rule. So just like before in the power rule, we bring that 2 down, multiply it by 3, that becomes a 6x. If we subtract 1 from that, what we're going to get is an x to the first power. 2x, well, you can think about that as having a 1 up top there and moving that 1 down. That's still going to stay a 2. That's going to become x to the 0, though, because when we subtract 1 from 1, we get 0. And we have to remember that the derivative of any constant, irregular number, is just 0. So cleaning this up is just going to be 6x plus 2. V prime, the very first thing I need to do here is I'm not even going to take the derivative. I'm actually going to rewrite this with a coefficient of 1 and an exponent of -1. So I haven't even taken the derivative yet, but I'm setting it up so that I can. Now I'm going to move that exponent down, subtract 1 from that exponent, take the derivative of my constant, which is 0, and now I'm going to rewrite. So just remember, since it was on the denominator and it had an exponent of 1 in the denominator, it became an exponent of -1. So if you want me to highlight that, this was in the denominator, so it became a negative here. That's the key move. Because now what we're going to do is we're going to move it back to the denominator. So now that I have it as a -2, I'm going to keep the -1 as the coefficient, and that goes back into the denominator and just becomes a regular x squared. I don't need to put the plus 0 in there. So when I write this entire thing out, we're going to have f prime of x equals, and we're going to go in this order, u prime to v, u to v prime, starting here. U prime is going to be 6x plus 2 times v is going to be 1 over x plus 1 plus, since we're using the product rule, u, 3x squared plus 2x plus 1, all times v prime, -1 over x squared. I'm not going to make you clean this up, distribute, etc., etc. Sorry, I forgot my plus 1 in there, but it is in there. But that's going to be our derivative. That's using the product rule. Using the quotient rule, similar type of formula, a little bit more going on. We still have to identify that this is dividing. That's what tells me quotient. And we have to identify u and v. So we have u and v. We're going to have u prime and v prime. So u is just 2 radical x to the third. V is going to be 2x plus 1. I'm not going to lie, v prime is going to be much easier to solve for. So taking the derivative of 2x, leave the 2 out front, just bring the 1 down. 1 times 2 is going to give you just 2. Keep the x. That 1, if we subtract 1 from that, it becomes 0. Anything taking the derivative of any constant, once again, is going to be 0. So that's just 2 times 1, which is just 2. Our derivative here is just 2. Okay, now u prime, slightly different. We can see that we have a coefficient of 2. Let's leave that in there. And before I even take the derivative, we need to rewrite this. Remember that this has a radical of 2, a root of 2. So what we want to do here is we want to write that as a fraction. Since 3 is on the inside, we make that the numerator, and the root is going to be our denominator. Now we can actually move that 3 over 2 down using the power rule. So we'll make that 2 over 1 times 3 over 2. We'll keep the x, and remember that we have to subtract 2 over 2 here, which is 1 whole. So always subtracting 1 from that exponent, which gives us a positive 1/2. Now we're just going to clean this up. So let's think about what 3 times 2 is. That's 6. 6 divided by 2 is 3. X to the 1/2. And we should remember that 1/2 power is going to go back into a radical. Fractions go back into radicals. Keep the 3. And remember that the x is going to go inside with a 1, and the 2 is the root on the outside. So that would be our final u prime answer. So writing this whole thing down, we'll call this whole thing dy dx this time. Since it asked us to take the derivative will be represented by dy dx. And we're going to go in the same exact order, u prime to v. So in this case, we're going to have 3 square root of x times 2x plus 1 minus, let's see, now we're going to go from u to v prime. I'm not going to include everything here. Let's just call that 2 radical x to the third, knowing that there's an invisible 2 with any square root, times 2. Now, normally we'd be done if we were using the product rule, but remember that with the quotient rule, we have to do a v squared. So the whole thing is going to be 2x plus 1 on the bottom squared. Now, there's some more math that is left to be had here. We could take this 2 and distribute it, etc., etc., but this is our derivative formula at basic form, so we would be done. Okay, product and quotient rule. Now, the very last one, so on your classwork, we're going to skip this one. You can actually write that in your classwork or just not include it. We're going to go directly to this very big problem down here. It is asking us not just to find the slope, but find the slope at x equals 1. So we have to find our derivative, okay? And once we find that derivative, remember from yesterday's lesson, we're going to plug in the x value of 1 to find out exactly what the slope is. So we can see that we have the quotient rule, u and v. So off to the side, I'm going to write u and v. And we're going to go through and we're going to find our u prime and v down here. So u is just going to be 4 over x squared plus 2. And v is 2 radical x to the third plus 6x. Now this might seem kind of intimidating, but our first step is going to see if we have to rewrite anything. Right here, I can see something in the denominator that automatically tells me keep that as a coefficient, but write that as a -2. So I haven't taken u prime yet, but I'm setting it up so that I can. Now I can use a power rule to take that derivative, multiply that -2 times the coefficient 4. And if I subtract 1 from that, I'm going to get x to the -3rd. Remember that the derivative of any constant is 0. So when I rewrite this, I can just write -8, my coefficient, on top, and x to the third on bottom. Remember, a negative exponent tells me to put it on the bottom of a fraction. I don't need to put the +0 there. For v prime, this becomes a little challenging because now we have a radical. One thing that I'm going to do is remind myself, if there is no number on the outside of the radical is 2. So when I write this as an exponent, I'm going to keep the coefficient. My x is my base. And now my exponent becomes this 3 and 2. The 3 goes on top and the 2 on the bottom. So I haven't taken v prime yet. I'm just setting it up so that I can. Now I'm going to use my power rule. So I'm going to do 3 over 2 times 2 over 1, x. And now what I also have to do is subtract 1. That's how I use a power rule. Subtract 1 from the exponent and get a 1/2. I also need to take the derivative of the 6x. So that's a 6x to the first. Bring the 1 down with the 6. So that's just going to stay a 6. x to the 0 power. Now we're just going to clean this up. 3 times 2 is 6. 6 divided by 2 is 3. 3x to the 1/2 is what this boils down to momentarily. And this 6x to the 0, remember x to the 0 is really just 1. So that's just going to be plus 6. Now, this would be great, but except we still have this fraction exponent that we should put back into a radical, just like what we did here. We turned this radical into a fraction. Now we're going to turn our fraction into a radical. Keep the coefficient as 3. Your x is going to go inside the radical. Remember that your top number is its exponent. The outside number is its root. And we're going to keep that other term out there. And that would be my v prime. So if I'm asked to find the derivative, I can put this all together using my quotient rule. So remember that I have to put this all together in a very particular order. U prime to v, u to v prime, making sure I'm subtracting those and dividing by v squared. So what this is going to look like is as follows. F prime of x, let's see, we have to start with u prime. So that's going to be in parentheses -8 over x to the 3rd. We're going to multiply that times v. So that's going to be 2 radical x to the 3rd plus 6x minus u times v prime. U is going to be 4 over x squared plus 2 times v prime, which was all of this thing right here. That was 3 radical x plus 6 all over v squared. So I got to take this whole thing and I have to square it. 2 radical x to the 3rd plus 6x all squared. That's a ton. And the unfortunate thing is we're not even done yet, because this problem asks us not just to find the derivative formula, but to find it at 1, find the actual slope at 1. So now our task is to go through and basically evaluate this at 1 to find the slope. It seems like a lot of work, but it's just the value of 1. So a lot of this stuff is going to be very, very easy math. So let's just kind of do some work in our head here. This is 1 to the 3rd power. That's just 1. So that's just all going to turn into -8 for that first group right there. The 3rd root of 1 to the 3rd square root is still going to be 1. So this is going to be 2 times 1, which is 2, plus 6 times 1, which is 6. We'll come back and simplify that in a second. Plug in a 1 here, we get 4 over 1 squared, which is just 4, plus 2. And here we're going to take the square root of 1, which is still just 1. So 3 times 1 is 3, plus 6. On the bottom, if I plug in a 1 here, the 1 to the 3rd is 1, square root of 1 is 1, so 2 times 1 is going to stay 2, minus 6 times 1, which is just 6. Oops, sorry, that was a plus sign. All squared. So solving this the rest of the way is going to look something like, let's just kind of clean up some work here. That's going to be -8 times 8 minus, let's see what we have here, 6 times 9, all over, let's see, 8 squared, that's going to be 64. One more time, this is going to be -64, multiply first, minus 54, making sure to multiply these two things on the top, all over 64. Our slope then is going to be -118 over 64. Now that seems like a ridiculous fraction, but that fraction is actually very close to -2. If I were to think about that as -128 over 64, that would be exactly -2. So that kind of gives us an idea of what our slope, our instantaneous rate of change is of that function f of x at x equals 1. I hope this helps. I know that was a crazy example. You won't have to do such crazy things on your paper today, but we're practicing the product and quotient rule and these crazy derivatives in between. Show your work, refer to this video. You guys are the best.